Hi, if you're watching this video, it appears you needed a little bit more instruction than what was on the lab. What you first need to do is stretch out the spring scales, make sure they're flat on the table. They should be reading somewhere around 10, but they shouldn't all be exactly the same. The next thing you need to do is line up this bottom spring scale so that it is on a vertical grid. The next thing I'm going to do is attempt to read the values on the spring scale. This appears to be about 10.8 newtons, so I'm going to write that down next to the spring scale. If I look at this one, to me this appears to be 11.1 newtons, so I'll write that down next to the spring scale. And the very last one I'm estimating to be 11.2 newtons. Okay, what you have to do is put a dot right in the center because that's where all these vectors start. Now I need another point that is on the vector, so I'm going to reach underneath and put a dot right where the metal bar reaches the spring scale. So I'm going to do that for each of these three. And then I'm done with the force table. I can remove this. Now, I'm not going to totally go into the detail here, but you have to pick a scale. If I want to pick a scale, and you should show your scale on the diagram, maybe one grid or 1 centimeter equals 1 newton. Then I would have to pick up a ruler and make sure that I drew this so it was exactly 11.1 centimeters, because that corresponds to 11.1 newtons. And this one would be slightly shorter. That would be 10.8 centimeters, because that corresponds to 10.8 newtons. And lastly, this would be 11.2 newtons, 11.2 centimeters, because that corresponds to 11.2 newtons. Now, the next thing you have to do is draw in the x and y components, because when we add more than one vector together, we found all the components. So this one will go to the right, and then from there I go up to this point. Measure this vector. That'll give you the magnitude. Measure the length of this vector. That will also give you the magnitude. Now for the vector on the left, from its tail, I have to go left for the x component, and from there I have to go up, and again you're going to measure this length. For example, if it was 5 centimeters, then it is a 5 Newton force. And you're going to measure this length. Okay, if it were 2 centimeters, it's 2 newtons because of the scale I chose. And let's call this vector A, this vector B, and this vector C. Then I'm going to do what I've always done in the past. I'm going to set up a little table, and I'm going to write down the x component. In this case it's a force, and the y component. So this is the force for vector A, the x component. This is a force for vector A, the y component. And then I do similarly for B. Now it appears that B went to the left, so I know that's going to be negative, but it goes up. That's positive. And vector C. That will go down. Write your values in newtons. So I should put the units up here also. Then what I'm going to do is I'm going to add them all together and then follow the lab from there. I hope this helped.